Hello everyone, this is Matteo from Start With Design. Welcome to a new episode of the FPGA meets DevOps series. In the previous videos, we integrated Vivado with Gitlab CI to automatically build the FPGA bitstream. What about simulation? In this video, I'm going to show how to run and debug Cocotb test cases locally and how to run them with Gitlab CI. We're going to use the system version IP we used in previous videos as device on the test. Let's begin. Cocotb is an open source Python library for writing RTL test benches. We're going to install it locally first so we can write and debug the test cases before integrating them with Gitlab CI. Create a new Python environment. And install Cocotb. We can check that Cocotb has been installed correctly with this command. We also install Cocotb bus, which is an additional library that has bus drivers and bus monitors for AXI, AXI Lite, etc. We install PyTest that will be used to run the test cases. We're going to use Icarus' simulator with GTK Wave to view the waveforms. I had to modify the RTL to run the simulation in Icarus, since it is not 100% compatible with the RTL code in the XPM libraries. If you use Model Sim or other commercial simulators, you can use the code without changes. You just need to add the XPM libraries to the simulation environment. Note that the Vivado simulator is not compatible with Cocotb. How can you debug your Cocotb test bench to inspect variables, run step-by-step, etc.? You can use PyCharm that offers remote debugging capabilities, but only in the professional version. We need to install the PyCharm debug server. Note that there is a known issue with the previous versions of PyDVD. If you're using PyCharm 2025.1, it works fine. And we have to add 2 lines of code in our test cases to start the debug server. Let's check out the code for the system version IP that has also a test case written in Python using Cocotb. Let's open the IP repo directory with PyCharm and have a look at the sim directory. The systemversion.py file has some helper functions to read the registers in the IP block and extract the various fields like version, major, minor, etc. Test systemversion.py has the test runner and 1 test case. Let's go through the code starting with the runner. We have sources that contains the path to the RTL code. In this case, there is only 1 file. Then parameters that we're going to pass to the simulator to configure the IP. We're going to export these parameters as environment variables so we can access them in the test case. The runner build phase is where the source code is analyzed by the simulator, and the test phase is where the simulator is running. Note that I have defined sim equal to 1. This is because Icarus Verilog doesn't correctly read the XPM library source code, so I replaced the XPM CDC code with an equivalent in RTL. Also note that there are some PyTest parameters. I have randomized major, minor, and build version. I can't do that inside the test case since those are Verilog parameters. Inside the test case, we assign random board type and revision. We can do that in the test case code since those are input ports. Then we assert the reset, start the clock generator, create an AXI driver, and read the various registers in the system version IP, comparing with the expected values. Now to run the test case with PyCharm, create a new run debug configuration of type Python debug server. Set the port to 9090. Set a breakpoint at the beginning of the test case and start the debug session. Now run the test. And you can see we can execute the Python code step by step, look at the variable value, etc. After the test case has completed, we have a few output files. We have test system version.log that contains the detailed log output. Inside Simmer build, we have a .fst file that we can open with GTK Wave. The file with the .none extension is the XML output that GitLab will use to show the total number of tests, how many passed or failed, etc. This file should have the XML extension, but it is an issue that has been fixed on the main Git branch, but not in the stable release at the time of the creation of this video. Update the Vivado Docker Git repo and rebuild the Docker image. This image has now Cocotb, bus, and Icarus Verilog. See the third video of the series for more details. In that video, I have shown how to integrate Vivado with GitLab. In particular, how we use the Gitlab CI YAML file to tell GitLab how to build the bitstream, what to save as artifact, etc. But the test case we have is specific to the system version IP, so it makes sense to have a Gitlab CI YAML file just for the system version IP. So we can run the same test for every design where we use that IP. GitLab has the concept of parent and child pipelines. We can have a config file inside the system version IP directory and reference it in the top level config file. So let's update the IP repo submodule in our example and have a look at the YAML file. We can see there is a call to PyTest to run the test, and we save the XML as an artifact. Now we have to edit the YAML file in our example like this. First of all, I have created 3 stages: setup, test, and build. The build stage is the same as the previous videos. Since the IP repository directory is a Git submodule, I had to create a new stage to do git clone and save the GitLab CI file as an artifact. That artifact is then used for the next stage, test IP. In the test IP stage, I include the GitLab CI file from the IP repo. Now we commit everything and see what happens in GitLab. There are the 3 stages in the pipeline, and the test stage actually runs the configuration file from the IP repo folder. And there was one test that was run successfully. That's all for this video. In this video, I have shown how to run tests for an IP as part of the CI pipeline. The tests are written using Cocotb, an open source library that can be used to write RTL test benches in Python. Also, I show how to use PyCharm to debug the test benches. If you'd like a more detailed video about Cocotb, please have a comment below. If you enjoyed the video, click on the like button and subscribe to the channel.